Welcome back. Today we're gonna, or next, I guess, we're gonna look at factoring quadratics in disguise. So what we talked about in the previous video on how to factor quadratics without the box will be helpful here. But the first thing that's important to remember, or to recognize, I guess, is that not all quadratics are gonna look like x squared plus 3x minus 5. A quadratic follows a specific pattern. So you're going to see three terms, a trinomial, and what you'll see is with the exponents, you're going to have a very clear pattern. It'll be this first exponent will be whatever the middle exponent is times 2. So in our traditional quadratic, the middle exponent is 1. If we multiply that by 2, we get 2, and that's our leading exponent. And then whatever our constant term is won't have an exponent or won't have a variable at all. So if we look at the one that's in front of us here, we've got the middle exponent, the middle term, whatever you want to think of it as, is 2, right? So if we take 2 and we multiply it by 2, we get 4. And if you look at our quadratic, our trinomial, that's what our leading variables exponent is, leading terms exponent is. So the last thing we check is that we have a constant term. We have a term with no variable on it at all. And we see that. So this is a clear pattern that will exist in all quadratics. And I'm going to factor this the same way I would factor any quadratic, especially using the tools that we just used in the last video. So I will take and set it up so that it's going to end up being a binomial times a binomial. And again, I start with thinking about what is going to multiply together to give me x to the fourth. Now, typically, you're going to want to split that, right? Because our middle terms are going to end up being x squared terms. So we want this to be an x squared and this to be an x squared. And if you multiply x squared times x squared, you get x to the fourth. And then the rest of this is very much like what we did in the previous video. So we ask ourselves, how do we get two numbers to multiply together to be -7? So thinking about, what multiplies to -7, that's going to be -1 and 7, or +1 and -7. And then I just have to sort of guess and check here. So I'll move through the guess and check again as an additional kind of way for you to see how this works. Maybe I try, +1 here and -7 here. And I guess I could go in order, right? We'll do this in order. So I actually have -1 written there and then +7 written. I'm trying this first option here. And then I check. So check my outside terms and my inside terms. When I multiply my outside terms, I get 7x squared. When I multiply by inside terms, I get -1x squared. If I add 7x squared and -1x squared together, I get +6x squared. Now, if I go back and look at my middle term, my middle term's actually -6x squared. So I got the right number, but I need it to be the opposite sign. That's a very easy fix to make. All I have to do is switch the signs on the numbers that I chose. So instead of being -1 and +7, it's going to be +1 and -7. And then look what that does to the rest of our check then. So when we check this, it's 1 times x squared, which will be +1. And then it'll be x squared times -7, which is -7x squared. And then if I just change those signs all the way down, I get the -6x squared that I needed. So my final answer, remember, we want you to write this out without all the work on top of it. It's just easier for us to see, is this. Now, there's one thing that I want to keep reminding you to check, especially with these factoring of quadratics in disguise. Make sure that whatever you have written here and here, is fully factored. So if we had actually factored this as x squared -1, that's a difference of squares. Mr. Middleman addressed that in an earlier video. So, this could have been factored more if that was x squared -1. Look for your sum and difference of cubes. You want to make sure you're being aware of all those special things that could happen. So this is fully factored because this is not a difference of squares. This is not a difference of squares, so we're good. Okay, let's try another one. Now this time, it's kind of interesting. If we look at our problem, it doesn't really fit our, our quadratic pattern, right? If I take that middle exponent is 3, and I multiply it by 2, that gives me 6. And that's not what my leading exponent is, my highest exponent in the problem. And the other problem is, actually don't have a constant term. My last term has a variable with it as well. But hopefully what you're noticing is that in all of these terms, I could factor out an x. Now, if I factor out an x, I get this. Now, based on our previous problem, we can hopefully recognize that, if we take this 2 and multiply it by 2, we get 4. It's a quadratic in disguise. So we can apply our factoring process to this problem now. What's important to remember, and I'm going to go ahead and write it out here now so I don't forget. For my final answer, I have to have that x in front. So I'm going to set it up so I don't forget that. That's part of my answer, right? But what I'm only going to focus on right now is factoring this piece. So we go back to our guess and check method where we set it up, where we know it's going to be a binomial times a binomial. Our first terms have to multiply to be x to the 4th. Once again, we know that has to be x squared times x squared, and that's because our middle term is a squared. We don't want to put x cubed here and x to the 1st here, because then when we multiply it out, as we're checking, we're going to have something that has an x cubed added to something with an x to the 1st power, and we can't add those together. So we make sure that this, whatever this exponent is, matches our middle term. And then we just do our guess and check. So we say, okay, we know these last two terms, when we multiply them, have to be 4. Okay. So then we think about, well, what numbers are going to multiply to positive 4? Now be careful with this, right? Because we have, the first one you guys probably think of is, oh, that's 2 and 2. Well, we could also have negative 2 and negative 2. And don't forget about 1 times 4 and negative 1 times negative 4. So we do have some possibilities here. I'm going to try one and see if it works. So we can start with 2 and 2. So let's start with positive 2 and positive 2. And then we check our outside. And some of you are already saying, this isn't going to work. I can see it already. That's good. I check my outside terms and my inside terms. And when I add those together, that's not negative 5x squared, our middle term. So I know that 2 and 2 aren't going to work. I can't switch them around. And I know that if I put in just negatives for that, it's still not going to be negative 5x squared. So I know my 2 and 2s aren't going to work. I can eliminate those right away. So that just leaves me with the 1 and the negative 4, or 1 and 4 and negative 1 and negative 4. And I'm going to use the clues within the problem, guys. I need to end up with a negative middle term, which means I need to use negative numbers in these boxes. And that's one of those little strategies that you're going to learn as you go through this process, that look at the clues within the problem. So let me get rid of some of my work here, and then we'll go ahead and try the negative 1 and negative 4. So if we try negative 1 and negative 4, let's try negative 1, negative 4, and see what happens here. So when I multiply my outside terms, I'm going to get negative 4x squared. When I multiply my inside terms, I'm going to get negative 1x squared. And when I add those together, negative 4x squared, I get negative 5x squared, right? So that's what I need. That's what I was hoping to get. Now, here's what's interesting about this problem. When I write my answer down, so, you're like, oh, yay, I factored it. I can move on. Well, kind of. In a previous video, Mr. Middleman talked about difference of squares. It's really important to watch for those. And I'm telling you that not just to be picky, but later on in the year, we're going to be factoring things that have trig functions in them. It's going to be really key that you recognize a difference of squares. We're also going to be doing some things in the very near future with rational functions. Again, it's going to be absolutely key, it's going to be vital, it's going to be a time saver if you quickly recognize and know how to factor a difference of squares. It shows up all the time. So if I see this difference of squares, I know, hey, there's two differences of squares, right? X squared minus 1, those are both squares. X squared minus 4, those are both squares, and they're differences. I'm not going to go through the process for factoring those because Mr. Middleman did that in a previous video, and you can go back and watch that if you need a refresher. But we could factor this to be this expression. When we ask you to factor, we want you to completely factor. So it's really important that you don't just stop after you have gotten the first phase done. Check that, make sure that it's completely factored. So there's my final factorization. It's completely prime. There's no more factors I can take out of that. I didn't forget to put the X in front because I factored that out at the beginning. Okay, I want you guys to try this one. Again, pause the video, come back when you're done, and check your answer. We really wanted to make sure you were paying attention here because once you factored it the first time through, there was actually a difference of squares that needed to be factored further, and then that also resulted in another difference of squares. All right, so you've got an opportunity to practice a little bit more with some of this, and then again, pop in if you have questions, let us know if you need anything, and then go ahead and get to practicing. All right, see you soon.